Hello there, I'm Thomas Hatsios, a British-American pilot flying the Boeing 777-300ER into tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to Zurich International Airport, runway 14 for an Lszh localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300ER airplane. So I'm going to start showing you the systems and the displays of the Boeing 777-300 ERX of the PMDG simulation in Microsoft Flight Simulator X. So I'm gonna start with the primary flight display. The primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the radio altitude above the ground level, the ground speed, the barometric altitude above the sea level, and the target altitude selected from the autopilot and flight director system panel. We have also the rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, and the selected value from the autopilot flight director system panel, the magnetic heading and track. We have the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We have the primary flight display, the altitude indicator of the aircraft, the pitch lander in degrees, 2.5 degrees tick marks separated, and we have the bank angle in degrees also. We have also the flight director and the autopilot modes and the crossbars for automatic or manual guidance of the aircraft, and the Lszh localizer for an Lszh localizer approach. We have also the angle of attack of the aircraft as it flies, and the flight mode annunciator with the autopilot and the autothrottle later on in the vertical navigation modes. So after that, I'm gonna show you the navigation display. The navigation display that displays the airports, the waypoints, the nav aids, the GPS position of the aircraft, and the magnetic heading or track. We have also the terrain radar display with the terrain map. Displayed with green, yellow, and red, the terrain levels, and also the sea, lake, and rivers with blue. We have also the weather reflections, and we have the route of the aircraft that we're gonna create using the flight management computer. I'm gonna input all the values of the aircraft data like its weight, its center of gravity, mean aerodynamic chord center of gravity, fuel on board, and the takeoff performance, the V speeds, V1, V rotate, and V takeoff. And then I'm gonna input the takeoff runway and the destination, the departure and the destination airports, and the departure and destination runways for arrival, and the intermediate waypoints the aircraft is going to follow manually or automatically using the autopilot and the flight director system panels. So we have pretty much an hour and 10 minutes left for this video time 12, so we'll continue with that. We have also other aircraft displayed using the transponder, the ADS-B and the ADS-C transponder. We have also, I'm going to show you the autopilot and flight director system panel with the autopilot engage and disengage switches, the autothrottle left and the autothrottle right, engage and disengage switches, the flight director, engage and disengage. We have also dedicated airspeed for the airspeed guidance of the aircraft to control the thrust lever and the airspeed. So we have the variable thrust modes and the fixed thrust modes. We have the flight level change, the climb continuous, and the autothrottle, the speed mode. So you can select an airspeed using the knots or in Mach, depending on the flight level we fly. So in higher flight levels we use the Mach speed instead of knots, nautical miles per hour. So we have also the LNAV and the VNAV, the lateral navigation and the vertical navigation. We have the bank angle limit and the heading select, hold switch. We can select the heading and we can select the hold. We have the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute. And we can select also a flight path angle of trigonometric degrees for flight of descent, flight path of the aircraft. So we also have the altitude selected from the autopilot and flight director system panel, the target altitude, and we have also the hold switch for the selected value. We have also the VOR localizer and for an Ilsloc ladder approach, and also we have the approach switch for the auto land functions of the Boeing 737-300ER airplane or any other airliner like Boeing 737, 747, 787 or Airbus or Airbus or CRJ aircraft. So it's pretty much the same logic in almost all airliner aircraft. So I'm gonna show you after that the thrust levers and the upper and the lower ACAS, engine indication and fuel alert system, the control of the FADEX, the full authority is the electronic control computers that control the FADEX. Using the thrust levers you give the signal to these computers, which is one installed per engine, left and right engine. We have two engines in this aircraft. So I will show you that also. Then I'm gonna come to the flight controls and explain some of the flight theory of the aircraft. So I will continue now with that. So then after that I will show you the overhead panel. The overhead panel that displays that contains the electrical system of the aircraft, the left and right engine, integrated drive generators, the electromagnetic alternators of the aircraft for alternate fuel, and the batteries for direct fuel. Mostly we have also the APU generator, the auxiliary power unit, and the backup generators. We have also the ADIRU, the Air Data Analytical Reference Unit, and also the flight control computers and the left and the right engine hydraulic pumps, and also the backup electrical pumps for this aircraft. We have also the air pressurizer C1 and C2 hydraulic systems that receives pressurizer from the left and the right engine, 59 stage bleed valves, and also from the APU system. If we have an engine failure, for instance, right, and so we have also the left and the right wind tanks, the center tank, the fuel system with the forward and the aft pumps, the cross feed valves, and also we have the fuel control levers for the engines. I'm gonna show you that also. I'm gonna restart the engine and then I'll set up the flight management computer. I'll show you also the wing and engine got the IC in the overhead panel, and the bleeder system with the pressurizer from the left and right engine, and the APU and the cabin pressurization system of the aircraft. So this is some of the systems I'm gonna show you. Also the radio communication panel, the transponder, the weather radar. So we have like an hour left for this flight, so we'll have to be a little bit more yes, we have so much time left, so I will start with this the primary flight display. Here you can see the FPT indicated, the ground speed which is 0, the target airspeed selected from the autopilot and flight director system panel. Also we have the barometric altitude above sea level. We have the rate of climb and descent of the aircraft. So this is the speed tape, and this is the altitude tape, and this is the vertical speed tape. This is the heading tape for the situation indicator with the magnetic heading and track. This is the flight director crossbars. You can set the autopilot instead, and we have the takeoff go round mode in the flight mode annunciator. So we have the radio altitude above the ground level and 2 feet, and we are 29.92 inches of mercury barometric pressure setting. Here we can see the navigation display. You can see the airports. Here is Switzerland, here is France, here is Germany. So you can see the terrain levels displayed with green, yellow and red. The required navigation performance and the required navigation performance and the GPS positioning. We have the magnetic heading and track. The next waypoint is gonna be overflying, and the ground speed and the wind direction and airspeed for the wind. So we can set inches of mercury hectopascals. We can set the meters. We can set the minimums here. So now you see also we have meters, 3050 meters for the target, 436 feet, meters above the ground level, above the sea level, excuse me. And we have 1013 hectopascals here. So we have the magnetic heading and track, we have the magnetic north pole and true north pole depending on where we are in the world. I'm gonna set this back to the inches of mercury. I'm gonna set a couple of values here. So you will see later the airport here that we are located and the route we're gonna follow, the flight plan. We're gonna create using the flight management computer over here, input all the necessary values that we need for this flight. So I will continue with that. You can see the auto throttle gates and disengage. So you will see the auto throttle message now here in the upper ACAS. Auto throttle left. So I will continue now. I'll see the auto throttle right. Also the same thing, the flight director on and off, the autopilot, so we can disengage the autopilot. So I will show you a couple of things now. Flight level change mode. This is the airspeed, indicated airspeed in nautical miles, knots or in Mach. So this shows the press volts, so you can select a higher value for takeoff, like 253 knots. You can select the AT, the climb continues, the VNAV and the LNAV also. A few more modes you can select for this guidance of the aircraft. So I will show you now. We have LV 35. So we have 10, 15, 16, yeah, 1 more hour left. So we can select the bank angle limit here of the aircraft. We can select heading and track. This is for the autopilot function. So if we select this, we can deselect it. We will reset the heading here to the runway we're gonna use for takeoff, like 136 degrees. I'm gonna set this also to the thousands and select the altitude here, 35,300. Here we have the vertical speed, so we can overlap one mode or the other at the time. You cannot use all the modes simultaneously, so because each mode is many times overlapping one another. So we have the flight level change or heading here, so you can see some different marks now for the pitch altitude, and we have 136 degrees here also heading. So I will set the flight level change, also the autopilot on now, like this. So you will see the AP here connected in the same mode. So this is the autopilot connected here, and you have the green light here also. So this is the AP autopilot connected. So we'll continue now. Show you a couple more modes. We have the heading, we have the altitude. Hold with the autopilot connected again. So you have altitude hold now instead. So a couple more modes. We have the vertical rate of climb and descent. We have the LNAV, I told you, the VNAV, very important, you will see inside. So you can select descent 2,500 feet per minute or climb like 3,000 feet, 3,500. So this is the vertical speed mode. So you will see a tick here, a mark in the tape of the vertical rate of climb and descent. That is between 2 and 6. That is 3,500 feet per minute. So we can select also the rate of climb and descent, vertical rate of climb and descent, in FPA, in flight path angle. So we can select how many degrees you want to descend or climb the aircraft as you fly. So this is a very interesting mode also. So you will select 3.5 degrees, you will have the tick marks here with the pitch ladder, 3.5 degrees. That is between 2.5 and 5 degrees mark. So you will remember that when you take off and then when you fly, you have to hold this up. It's out. You also have the vol localizer, and the approach switch is over here. The vol lock and the approach. So this is so much for the autopilot lesson. We can disengage. As I show you the autopilot, you will see the warning here, and we have the autopilot disconnected here. Autopilot disconnect. So you cancel the warning. You see the flight director again. Reset this switch. You see how you use it. Just pull this out. Reset the switch here and reconnect the autopilot. Now the autopilot is connected again. So you can move this control yoke or press this switch here and you disconnect the autopilot again. So you have the autopilot disengaged again. I will show you a couple more things interesting about the Boeing 777. So I will continue with the rest of the aircraft. I will show you. So I have to remember how much time we have. So we have pretty much like we have a few more time left. So before starting the engines, I will show you the flight controls here, the yoke. I will show you the tiller for the nozzle steering and the rudder pedals. Also, I will show you the thrust levers. So you can see here. Here we have the flaps. We use the flaps for increasing the lift of the aircraft. Also the upper and lower ACAS here and the indication controller system. Here's the landing gear, the alternate gear in case we have a failure with the normal gear. We have the auto brake system for landing and rejected takeoffs. So you can see again the Boeing 777 mark here. The brand that we fly this aircraft. So you can tell this is the Boeing 777. So we will continue now. We'll use also the this is the horizontal tail trim stabilizer of the aircraft. We use the speed brakes also to slow down the aircraft. We remove the thrust levers when the speed brakes are engaged. The speed brakes will disengage, will retract automatically. So if we move the reverse, the speed brakes also will extend automatically. So you will see here the reverse engine thrust, the blocker doors of the aircraft open. So we have reverse now for this aircraft, the Boeing 777. So you can see the thrust reverses here. And the speed brakes are engaged, and this is to slow down the airplane after a touchdown with flight, for instance. So we can disarm this. You will see the blocker doors close like this, and the speed brakes will retract automatically. We can re-engage it like this. You will see the thrust reverses open. You can disarm again. So this is how the thrust reverses, how it works. For slowing down the airplane in flight. You can also see a couple more views here. Hope you like it. So this is the wing view of the airplane. The top of the wing and the other wing view here of the Boeing 777-300. So I hope you like these wings. So now we'll show you a couple more things. So we'll disarm the thrust reverse. Here we have the auto throttle disengage disconnect switch, and this is the takeoff go around. This and this is the left and the right engine. You can see the flap marks here, the decrease. So here in this yoke we have the horizontal tail, the stabilizer. We have the aileron trim. We have the horizontal tail trim. for the horizontal tail of the aircraft, so you can balance the aircraft inside. You can use the horizontal trim here, the stabilizer, so you can see also the degrees, how many degrees you want to use the stabilizer trim, up and down, nose up or nose down. And in case you have a failure in the hydraulic system, the CNDR or the R, you can disconnect the electric trim stabilizer here from the autopilot and the auto throttle function of the aircraft. So you'll have only the mechanical trim over here. And here in this switch. So you have the fire extinguisher for the left and the right engine. You have the parking brakes here, up and down. You have the radio communication panel, the weather radar, the transponder, so you can see other aircraft flying around you. And this is the rudder, the vertical tail stabilizer, and the aileron string. That is not necessary to use any trim at all, but you can use it at least for the horizontal stabilizer. It's helpful. So you can use on the yoke if you wish. So we have about 13, 18, about 45-50 minutes left for this video to end. So I will continue with the thrust levers. I will show you here we have the indications of the engines, as you can see. You can see also other systems of the aircraft. So I will show you also the overhead panel, the electrical system over here, the ADIRU, the aerodynamic reference system, the hydraulic system, the wing and fender tanks of the aircraft with the fuel on board, and the auto start system for the engine, the cabin pressurization and the bleed air from the engine system, the pneumatic system of the airplane. So I will show you now the engines, the fatigues. You can see if I move the thrust levers, I can actuate the thrust. I can disconnect actuate the thrust. So you will see the thrust change here, the mode DN1, which is the low speed low pressure compressor stage of the turbofan turbojet engine, the exhaust gas temperature per engine, and the green, yellow and red marks values. You can see some information here, some warnings about other systems and the flaps. The landing gear is down, the outflow valves, the duct pressure of the pressurizer, I told you. So you can see the pressurizer increase at least, the turbo fuel on board. So you can see exhaust gas temperature and one stage, and 2, which is the high speed high pressure compressor stage of the turbofan turbojet engine, the fuel flow per engine per hour in thousands of pounds right now, or in thousands of kilograms, fuel pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So a few more minutes left to go for this flight. So I need to be a lot more brief right now. So I will show you now the thrust levers. I will talk to you about the theory of the thrust levers, how to use them to increase the thrust, to move the aircraft forward, to accelerate in the runway. So I will talk about that later. I will start with the fatigues. The fatigues are the full authority digital electronic control computers, specially designed for turbofan turbojet engines and jet aircraft like this airliner, the Boeing 2300ER. So if you increase the thrust lever's thrust, you will give a signal, or you can decrease it inversely. So you will give a signal to the fatigues. The full authority digital electronic control computers, one installed per turbofan turbojet engine, one installed per engine with dual channel redundancy. If one channel fails, the other takes over. So you have full authority digital electronic control computer function like the N1, which is the low speed low pressure compressor and turbine of the turbofan turbojet engine, the exhaust gas temperature per engine. Then 2, which is the high speed high pressure compressor and turbine of the turbofan turbojet engine, the fuel flow per engine per hour, the oil pressure or quantity, oil temperature in the vibration of the N2 stage of the engine. So you will see all these indications in the upper and the lower ACAS, the engine indication through alert system displays and the multifunction displays. So you give a signal to the Hatsios control the fuel flow to the engines. They control also the rotor speed of the shaft, the fan speed, like the rotation speed. This is the N1 and the N2 of the low pressure compressor and turbine, the high pressure compressor and turbine, and high speed shaft and low speed shaft. So the N1 is the low speed, low pressure compressor and turbine of the turbo engine, and the N2 is the high speed, high pressure compressor and turbine of the turbo engine with a high speed shaft. So you have two axial shafts in turbo engine. So you have the fuel flow per engine, so you have also the outflow pressure from the 5th and 9th stage of the turbo engine. So the Hatsios also regulate this pressure inside the engine stages. If you have an overpressure, it opens the outflow valve to pressurize the engine. If you have an underpressure, it closes the outflow valve to increase the pressure inside the engine. So it optimizes the fuel mixture also as you climb or descending to higher or lower altitudes with different airspeed. You have a different flow rate of air into the turbine of the aircraft, so into the turbofan engine. So you have a different fuel mixture requirement depending on the thrust and the airspeed you want to fly and the altitude. So it optimizes all these things. Also the engine start, engine shutdown, some failures. We will explain more into all these things. So it's a fantastic thing to have in an aircraft, the Hatsios. So I'll talking now about the flight theory of the aircraft, how to use the thrust levers to increase the thrust to accelerate into the runway for takeoff. So I will show you also the flight controls of the aircraft and talk to you about the wings, how to produce the lift force, and also how to stall the aircraft. So how to recover from a stall. So also this thing you can use the thrust levers again for thrust. So with this airplane, the Boeing 777-300ER, we have right now 254,000 kilograms of takeoff weight, which is below the maximum takeoff weight for this aircraft, or 521,000 pounds. We have only 46,000 kilograms of fuel on board, or 102,000 pounds, which is 30% of the total fuel on board we can contain in its wing and center tank. And we also have 30,000 kilograms of passenger and cargo, also below the maximum for takeoff. So in total we have 246,000 kilograms of 131,000 pounds. We're gonna use 15 degrees of flaps and 4 degrees of horizontal tail stabilizer trim for the takeoff. So we're gonna need an airspeed of about 270 kilometers an hour in order to produce the required lift force from the wings and takeoff from the runway, or about 154 nautical miles per hour. So I will show you that also. So if we have an airspeed below that, we may gonna stall the wings of the aircraft. So the stall is what it makes the aircraft fall back into the ground, lose the lift ability from the wings. The wings produce the necessary lift to hold the aircraft up into the air to make it flyable. So the lift is the force that overcomes the weight of the aircraft, that is equal to its mass times the acceleration of the gravity. Also the thrust from the engines, the symmetric thrust from the two engines in the left and right wing, also overcomes the friction from the skin of the air friction from in the skin of the aircraft. So it overcomes the drag. The thrust overcomes the drag, and the lift overcomes the weight. So this is the principle we're gonna use now, the Newton's physics, first, second, and third law of kinematics. and some Bernoulli theory of fluids and aeronautical engineering, aerospace engineering, and mathematics, and derive some calculations for this aircraft as it flies. I will show you the symmetry of the wings and the center of gravity, where they are positioned usually, and how to use the forces from the flight control surfaces to control the aircraft in flight, have directional controls. So you can see the flight controls here, also the outside view now of the wings. So you can see we have the two engines symmetrically positioned in the aircraft vector, the fuselage, and also this makes the aircraft move forward only, not climb like a fighter jet or other flying machine. So you need the wings to produce lift, of course. So you can see the engines, the thrust they produce. You can see also here's the wings that produce the necessary lift. We have the center of gravity positioned about here, where is the 25% of the mean aerodynamic chord, the 25% of the Mach. So it's the center of maximum aerodynamic pressure, and also the center of stall, the position where the stall will go to feel usually. So it's also the position of the center of gravity of the aircraft. About here you can shift the center of gravity forward or up. This position by moving passengers, cargo, fuel. So you can use also the flight controls of the aircraft for steering. I'll show you now, and the moment arm. So you can see the wings when the aircraft accelerates to the takeoff speed like 270 kilometers an hour. You can see the wing surface. The bottom surface is more flat, so the airspeed, the airflow of the air mass is gonna move slower below the wing, while the top surface is more curved. It has higher curvature, so the airflow of the air is gonna be faster above the wing. So the air pressure will be lower above the wing. So lower airspeed and higher pressure below the wing will bubble up the aircraft into the air, and lower and higher airspeed with lower pressure we're gonna make a suction up into the air. So you will have differential pressure between the lower and the top surface. So you will have a positive pressure below the wing and a negative pressure above. So this is gonna be caused by the airstream. Also the stall speed. I told you the stall speed is gonna make the aircraft fall back into the ground for a given angle of attack of the aircraft. We also have here a couple more things. Is the horizontal tail stabilizer. You can see we have the moment arm. The moment arm is the force times the distance from the center of gravity all the way back to the horizontal tail over the surface area of the horizontal tail. So we have the distance from the center of gravity all the way back to the horizontal or vertical tail over the surface area of the whole horizontal tail, or the elevator or the rudder. So you can use that surface area over times the distance over times the airflow per second of the air mass times the acceleration of gravity. So you can climb and you can descend like this using the forces from the elevator and from the wings, from the control surfaces like the ailerons and the spoilers. So you have also moment arms like this, moment arm forces. So this is what makes the flight controls deflect the airflow. So you have another airliner here for takeoff into the runway. So looks like a CRJ. Or maybe an MD-80. So I will show you now Also the overhead panel. So we have a few more minutes left to go for this slide. Also the flight controls, how to use the side stick for controlling the flight control surfaces of this aircraft. So I will start now. Show you the side stick first and the yoke. So you can see the yoke. We have the control column and control wheel we use for the elevator for climb and descent, and for the islands, so the spoilers, bunker left and right. We also use the rudder pedals for steering left and right, the yaw of the rudder, and also use the brakes from the rudder pedal. So we also have the tiller for the nose wheel steering here. So you can see we have the yoke here for climb and descent, and also bunker left and bunker right. You have coordinated controls also. You use all the and this is over interconnected, the left and the right side. So you can see the side stick I'm using here for controlling over here. You can see also in my computer screen that I'm having proportional input between my side stick and my yoke. So you can control all the flight controls. You can climb, descend using the elevator, bunker using the ailerons and the spoilers, using the rudder pedals for the rudder, and also the horizontal tail trim here, the stabilizer, and also the thrust levers like this. So you have the control of the aircraft in terms of the size. You can leave neutral if you wish. So it's pretty much good for this simulation for the Boeing 777-300ER. Now I'm gonna show you the outside view and how to use the flight controls, also using the side stick with the same principles. So you can see here we have the outside view of the airplane again. So we use the side stick for controlling over here to have control over here. So you can see I'm using the side stick for the elevator for climb, descent, pitching up and pitch down, also for bunker left and bunker right. So you can see I can climb, I can descend if I have an effective airspeed in flight. So I can change the flight path of the aircraft. So this is what helps me control the flight path of the aircraft if I apply the necessary thrust from the engines. Now we'll continue to the rest of the sections, like the overhead panel and the multifunction display systems, and make the engine start demonstrations. So I will show you the rest of the systems now. So I'm gonna come over here. So you can see we have the left and the right electric system. We have also this. I show you all the airspeed, the barometric altitude, the attitude of the aircraft. We have laser gyroscope, GPS receivers, and pitot static and pitot dynamic sensors. So we use the system, the ADIR, the data announcer reference unit. In the overhead panel we have the magnetic heading and to North Pole. So this is being controlled by the ADIR over here, this switch over here, your data announcer reference unit. So also now so you can see here we have all the modes we need for the ground maintenance. Here is the circuit breakers. You can reset if it pops out. So you have a nice view here of the cockpit inside. So you can see we can use the same systems again, the same principles from this side. Everything is working the same, and we have maybe a better view of the cockpit. So you can see the speed brake is 10. The flaps, I'm gonna set the flaps for takeoff here. Up 15 degrees, so you can see the 15 degrees mark here. After the one we come down, I'll select 15 degrees. So you can see also here the controls. You can see the autopilot again. One more nice view, more clear view with the modes here of the autopilot and the other panels. So we also have the landing gear here, the flight management computers, some other couple more systems, the horizontal tail trim, stabilizer, cutout, parking brakes up and down, part stickers for the engine. So I will continue now with the overhead panel. So I will continue now with the overhead panel. Also, you have the left and the right engine with the great drive generators installed in the engine gearbox. Receive horizontal shaft torque from the engine and rotate its own axial shaft that contains electromagnetic alternators and often south-pole electromagnetic induction. So it produces 120,000 kilovolts of or 100,000 watts of alternate current, 400 Hz frequency, and we can have left and right engine IDV, the direct driving generator, and also the backup 25,000 kilovolts, and the APU another 100,000 kilovolts in total. We can convert some of this current into from alternate 400 Hz frequency directly using the transformer rectifier. We can also use the battery 28 volts 48 ampere hours direct current and convert it into alternate using the static inverters, usually 5,500 kilovolts from the battery. So we can use other systems. Also in left and right engine hydraulic pumps installed in the gearbox, maybe also in the electric backup. We have also you can see here, so we have the Adiro system that contains all the systems for the air data computer, like the airspeed, the barometric altitude, radio altitude, rate of climb descent, the altitude of the aircraft, the gyroscopic acceleration, the laser gyroscope, and also the GPS position and the magnetic compass. So we have the left and the right engine here with the great drive generators. We'll start the APU for making a demonstration of starting the engine, so you can connect the external power also. So we'll have here the primary flight control computers, the thrust symmetry compensator. I don't know if you can see here some of the systems, the Adiro. We have the passenger oxygen, the runway turbine, the hydraulic pumps. I can show you. If we turn off, we're gonna have some failures happening, turning off the hydraulic pumps, so they will pop up. You can see now in the warnings over here. So we have the hydraulic systems fault and some flight control, including the stabilizer. The auto running keeps popping up some more systems, the brakes. So we can reset this by turning on the hydraulic pumps. We need also full flying. We need all the systems. So we're gonna turn to the auto. We still have the fault for the electric, the C1 and C2, which also are pressurized. We can show you. We can turn off, I believe, the electric also. You will see the electric off. The drive generator, electric, and the backup generator also. So I'll turn on again. Come very quickly. Also show you. We have the left and the right engine. General electronic engine control for the fighters, and also the auto start system. You can turn on and off. The normal. The APU and the cargo fire, the fuel jettison, arm and disarm. You can select how much fuel to dump in flight from the selected tank. So we have the left and right wing, the cross-feed valves, the fuel pumps on the left and the right wing, and the center tank pumps. So we can also control the wing and engine RDIs like this. This is some lighting for the aircraft and the windshield wipers. So this is the main principle. For that we also have the left and the right engine here, the pressurizer. We need for cabin pressurization, wing and engine RDIs, air conditioning. The APU we need for starting the engine. So you will see some faults now happening after a couple of seconds. So we turn off these things. You will see also some faults, bleed isolation, bleeder and hydraulic pressure. Here I told you the pressurized C1 and C2. So we're gonna lose flight controls like this by not having pressurizer for the hydraulic fluid. The duct pressure, we're gonna lose the cabin pressurization system. So these things you need to know about the Boeing 777 300ER. We're gonna use the APU here for starting the engine. So we have a few more. This is the overhead panel main principle. Now we'll go show you one more last thing. This display over here. So we have the multifunction display and the flight management computer. So we have the systems here, the display, the engines, the starters. You can see the APU is on, so we can start the engines if we turn them on. We have the checklist, the normal menu before start, what we need to do, couple of items to complete. Checklist is complete, no normal menu also if we have a failure. Communications, navigation, synoptics. So the doors here of the Boeing 777-300 are closed, and you can see the cabin is pressurized, the gear. You can see the temperature of the brakes and the pressure of the tires. The left and the right engine integrate drive generator also in the overhead panel. You can see the diagram here, the electric, the digital display, main battery, the voltage of the battery and the discharge, and also the APU is on here. Auxiliary power unit. So you can see the generator from the engine left and right, and the drive connect. And also we have the bus ties. So we have the left and the right engine, hydraulic pumps and fluid, and also the C1 and C2 air pressurized electric. So you need air pressure from the engine to again pressurize it. You can see the 3000 psi per system, 9000 psi, 3000 and 3000 separate, so it's 3000 each own system. So we have also the throttle valves, the left electric, the right electric, left engine, right engine, and the consumption of the fuel of the hydraulic fluid. The fuel on board, left and right wing, and the center tank, the cross-feed valves is open, and the total fuel on board, and the engine symbol, and the APU also. The air system, the pressurizer, left and right engine, duct pressure, left and right engine, the temperature of the, and we can use pressurizer for hydraulic fluid. You can see C1 and C2 hydraulics here. Pressurization. With an engine there is air conditioning and cabin pressurization. So if I increase the thrust from the engine, the thrust level, you will see the duct pressure here increase. So if I decrease the thrust level, you will see duct pressure. You can see the bleeder from the 5th and the 9th stage of the left and right engine and the APU. So one last step, the flight controls here. You can see the flight controls of the Boeing 777. So you can use these to move around the airplane. Flight controls, the rudder pedals, also the other side here. So you'll see everything is working normally. You can see the position of the horizontal tail and the rudder stabilizers. You can see the wings, the engines here, the horizontal and the vertical wing and the rudder. So this is all in all. In this we go back to the engines because we're gonna restart the engines here. So here we are right now. This is our position. We have like maybe I don't know, a few more minutes left to go. So we need to set it on both engines, shut them down. So you will see the reconfiguration on the overhead panel, and also here you'll see engine shut down when the N1 is decreasing. Engine shut down the warning system. The exhaust gas temperature decreases. Fuel flow is 0, and the N2 also decreases. So you will see in the outside view here the spinning, the right and the left engine. These turbophones are coming to a stop. So I'm going inside. We can restart using the engine or the start system over here, the left and the right engine simultaneously. So we have a few more minutes. You can see the M1 increases. Also the N2 above 20%, we can restart the engines. We have only pressurized air inside the engines right now from the APU, which is admitted from the APU bleed air. So we can restart now by admitting the fuel into the left and right engine, opening the fuel control levers. So you will see the fuel flow increase here from 0. Here we go, we have the fuel flow, and here's the left and the right engine totally working now. So we only need to complete one last step here before taking off. So we have about 8,000 rotations per minute. We can use the flight management computer one last step very quickly, very quickly. So we need to use this the menu, the FMC. You can see the model, the Boeing 777, the position, this airport. Lszh. I'm gonna use set inertial GPS position if we have to reset the ADIRUS. So we have the zero fuel weight. It is input automatically with the gross weight and the fuel on board. 5% of reserves, 100% of cost index here, and the cruising altitude 25,300 feet over here. We can set the cruise altitude. We can set the route from this airport back to this airport. We can select other airports if we like. And the runway we're gonna depart. Departure and arrival. This runway transit fix. And arrival Lszh. This runway transit fix. So we have the legs. Cancel the discontinuity, activate over here, and execute over here. Activate and execute. So we have these only one step, the flaps. The center of gravity here is automatic. We will need to insert the flaps 15 degrees. Center of gravity automatic, and the takeoff speed automatic. 153, 140, and 154 knots to use gross weight, and this runway we're gonna use for takeoff. So we have a couple more minutes left for this flight. I'm gonna taxi now into the runway for takeoff. I have to taxi into the runway, so disarm the parking brakes, advance the thrust levers, and use the tiller here for steering. So we're gonna use as much thrust as we need. We don't need too much thrust, and we have the runways open here for takeoff. You only need to come into the runway 14, so we can see in the GPS map that we are in the correct runway, and the right heading, and the ILS also. Frequency is tuned automatically. So I will align now, set the parking brakes. Only one last setting, maybe here the L knob. We have the flap set here into 7 at 15 degrees. Here we are, 15 degrees flat. The horizontal tail is set automatically, so we only need, you're gonna see the route here, all the information is been complete. So this is where we are right now for takeoff in this runway. From this taxiway we came over here, so only one last step for the takeoff. I will advance the thrust levers forward. You will see the thrust stabilize over here for takeoff, the markings. So I disarm the parking brakes again and go. And we have like 18 more minutes for this flight. So we have 100 knots or 180 kilometers an hour. V1, we rotate. So here we go, we rotate. We have the positive rate of climb. Landing gear up. Select the landing gear up. And here we go, we have the positive rate of climb. Keep climbing. Trying to pitch down a little bit, not to pitch up too much because we're gonna stall. So you can see we are 2,500 feet above the ground, but 4,200 feet above the sea level. We climb with 5,900 feet per minute, and the airspeed is 232 nautical miles per hour. The ground speed is 230. So you can see the altitude we bank a little bit. We have also the GPS position. You can see the terrain map here. So we need to make a turn now. We keep climbing. So we're gonna follow this route. You're gonna see also we have the stall speed here, this marking. We have to avoid not to stall the aircraft. So we're gonna keep bank rolling like that. We are like 8,000 feet above the ground level. So this is a general overview of the cockpit just after takeoff. So maybe we're gonna see the runway in a couple of seconds. So we can see, have some nice view over here at the side as we keep flying. Also the runway below us and some star sign. So we're gonna have the view here, the Boeing 727, a nice view as we keep climbing. So this is a nice view of the airplane and also the rig and the galaxies. Hope you enjoy the way we fly with about 500 kilometers an hour right now. As we keep climbing, 500 kilometers an hour or 250 meters per second. This is a nice view here of the airplane. So I'll go now inside to show you all the general view from inside as we make this turn. We're gonna turn into the waypoints for the rest of the flight as we keep climbing. So we have 14 more minutes for this flight. So we are this altitude 13,000 feet. You can see the airspeed, the ground speed. We need to overfly the next waypoint. We use the horizontal tail stabilizer whenever necessary, and maximum thrust for takeoff. Flight 14,000 feet. Decline a little bit faster. $16,000 feet. Gonna have the max speed also. It must be like max 0.4 or about 550 kilometers an hour right now. $17,000 feet. Keep climbing. We have like 12 more minutes left for this flight. So we need to intercept this waypoint now. I will come here and select the direct to this waypoint, execute, and also maybe we're still going this waypoint. We keep flying manually, keep climbing up. So hope you like the way this airplane operates. You can see the waypoint we have to follow. The next waypoint is this Z2 Alpha. Zui, actually. You can see the ground speed, some information. So we have this waypoint here in the map display of the GPS. The location of the aircraft right now, the airport here, the stars. So we keep climbing a bit higher rate. $30,000 feet. We're gonna have some stall warning now over here. We keep climbing. 30,000. So I'm gonna use maximum of the throttle. For climbing. So we have about 12 more minutes left for this flight. So we're gonna have a higher, more flight time this time than we usually do, because I finished it faster, the explanations before takeoff. So we are just 20,000 feet. Keep climbing a little bit higher. We need to see the chemtrails and 32,400. $600. We must have the chemtrails now. Here we are, chemtrails. The frozen vapor from the turbofan engine. So we fly with about 600 kilometers an hour. Overflying the St. Gallen Lake, we're flying straight into the Bayern Munich area. The Bayern Munich. So this is our spacecraft for tonight, the Boeing 777 300 ER. This beautiful airplane, 33,000 feet. So we have the Germany, the Bayern Munich in front of us. We keep flying, we have the Galaxy. And this lake and the Swiss Alps here. So I will come now inside. We need to come back to the airport. So I will make the turn now for the airport. So we are still flying manually to this 3,000 feet. We're flying, you can see the max speed now. So maybe I can retract the flaps now. We can increase the max speed. So we have like 8 minutes left for this flight. So we keep turn back to the airport, 8 more minutes. We have the Bayern Munich in this area with Germany. So hope you like this view of the airplane as we keep turning back into the airport. We're gonna fly with 900 kilometers an hour or 300 meters per second. Our airspeed right now. We have the frozen vapors here. And fly manually. We also have, as I told you, to go back into the cockpit to set up the flight plan for the return. So we're gonna use also the autopilot engage the altitude hold switch here. So we have the autopilot engaged now. I'm gonna use those. So we have like 8 more minutes left for this flight. We keep flying 35,000 feet here with 900 kilometers an hour or 300 meters per second. So this is our spacecraft for tonight, the Boeing 737 300ER, 35,000 feet above sea level. So we're gonna stabilize here. We need also to use all the direct 2 now. Over here, C114, direct 2 and execute. And the arrival airspeed. So we have the legs, the arrival airspeed, and we're gonna start descent now. I'm gonna start your descent. And also decrease the airspeed a little bit. As we keep descending, so the thrust levers will be decreased automatically. So the thrust over here, we keep flying with Mach 0. We still have the handbrake. We still are at high altitude right now. So we have like 6 more minutes left for this flight. I'll keep going down into the airport. Fly with 300 meters per second or about 900 kilometers an hour. Keep descending. Also use all the speed brake and the altitude descent. Hold here and disarm the autopilot like this. Use the landing gear also, slow us down a little bit. So we have like 5 more minutes left for this flight. We keep descending over here. I'm gonna use also lower airspeed now for approach. And also use some flaps. We're gonna make some flaps. Need to slow down as we're descending. So we need to turn into the direction of the airport over here. Having the direction over here in the map. So we are 11,000 feet. Keep descending. Having some 4 more minutes left for this flight. So hopefully we're gonna make it. 10,000 feet. We have the river here. Keep descending. Eight thousand feet. So we are 6,000 feet over here. We're much closer to the airport. So you can see where we are right now as we are approaching the airport. Much closer. So we're gonna use this view now here for the approach. So we have the airport inside. We have a few more minutes left to go. We are 5,000 feet above the ground. So you can see the Lszh localizer. So we have 34, 17 minutes. So we have 1 more minute left to go. Before this video will end. So I need to come a little bit closer. So we keep going down into the runway manually, as you can see. We have the Lszh localizer here. We are aligned with the Lszh localizer, all the information we need in the display. We are 1,000 feet. Keep coming down. We have everything manually. The engines, the throttles, over here the flaps. So we're gonna slow down the engines. $50, $30, $20, $10. Parking brakes and reverse thrust. So this is how we land. Like this. We made a nice landing.